Hi everybody and welcome to a new exciting video in the PyTorch for audio and music processing series. In the previous video we saw how we can make predictions with a PyTorch model. In today's video we'll take a look at custom datasets and precisely how we can build our own audio custom dataset. Okay, but you may be wondering what dataset are we going to be using for creating this custom dataset? Well, the answer is the UrbanSound 8K dataset. Let's take a look at its website. This is UrbanSound 8K dataset. Here you have a description of the dataset and a bunch of other information. But if you do want to download the dataset, you go down here, the download form, you fill in the form, you submit it, and then you get a download link you can use to download it. Okay, let's go back to the description of the dataset real quick. So this dataset contains 8,732 labeled sound excerpts. Cool. We'll take a look at what classes of sounds we have in this dataset later on in this video, but for now, let's go back to PyCharm. Okay, so what we want to do here, practically speaking, is creating a custom PyTorch dataset. In a previous video, I showed you that there are a couple of fundamental classes that we can use when dealing with datasets in PyTorch. One is called dataset, and the other one is called DataLoader. So dataset basically has or stores all the information regarding our dataset in terms of samples and annotations, and DataLoader is just a wrapper around the dataset class which we can use to load the different samples basically in real time. Okay, so we're not interested in DataLoader here, but rather we're interested in datasets and creating a custom dataset. So as a first thing, we want to import the dataset class. And so we'll do from torch.utils.data, we'll import dataset. Now, this dataset class is a base class, and so we need for our custom dataset or concrete class to inherit from dataset. So we'll create a class which we'll call UrbanSoundDataset, and this class will inherit from dataset. Now, a concrete dataset, a PyTorch dataset class, should implement a couple of magic methods. The first of which is a length or len. So we'll pass this for now, and the second one is get item. So this one here, and let's call this argument index, and we'll pass this. Okay, so what are these two arguments? Well, length is basically just the method that we use to define how to use the len syntax. So this is basically, so the moment we implement length, we are defining how to calculate this len here. Okay, so USD is just the UrbanSound dataset object. We take the length of it and we basically take the length. And in our case, what we want to do is quite simple. We want to have the number of samples in the dataset. So we'll implement that in a second. But before, let's take a look at get item. So what's get item? Well, get item is another magic method, and you may not be familiar with get item, but you definitely are familiar with what get item is used for. So take, for example, a list. So we have a list. So whenever you use this syntax here, for example, a list, index 1 of a list, well, under the hood, you're actually using get item. And this can be rewritten as a list dot get item underscore underscore, and we pass in here 1. Okay, so this is basically what we want to have. We want for our UrbanSound dataset to be able to use this syntax here, and we want to specify how to get items from our dataset. Okay, so that's great. Let's get rid of this as we don't need them. Okay, so we know that we have to implement these two magic methods, but before we do that, of course, we need a constructor. Okay, so let's pass for now. So what arguments do we want here? So we want to pass a couple of arguments. So first, we have the annotations file, and then we'll pass the audio directory. So what are these things? Well, the annotation file is a file that has all the annotations, and the audio dir or audio directory is just the path to where we store all the audio samples in the dataset. Now, to understand a little bit better what these are, let's take a look at the UrbanSound dataset. So I've already downloaded here, and as you can see, so I'm in the UrbanSound 8K. So here we have a couple of folders. So one is called metadata, and in metadata we have this UrbanSound.csv. This is our annotations file. So let's open this and take a look at it. So here we have all the different annotations. So if I go down here, yeah, you'll see that we have 8,732 annotations. Remember, yeah, the first row is just the column name, so it doesn't count as a sample. But now let's take a look at the different information that we have here. So the first is the slice file name. So it's basically like the file name of each audio sample. Then these are the ones we really don't care that much. Let's take a look at this one. So this is the fold, and fold, it's a number 5. And as you can see from here, so if we go back and we go into audio, so the samples are divided into 10 folds. So if we have fold 5 here, it means that this file is in fold 5 indeed. Okay, and here we have like all of the samples for fold 5. Okay, and then we have the class ID, which is basically the label. Now, if you want to have a mapping between the label, the label and the index, what we can do is just go back here and take a look here. So we have 10 classes. So a zero index equates to air conditioner, 1 maps to car horn, 9 to street music. So you get an idea. Perfect. Now you should have an understanding of the UrbanSound 8K dataset and how it looks like and the different things that we want to fetch. So let's go back to our PyCharm. So here we have the annotations file, which is the path to the CSV file that we just saw, and audio directory is the path to this directory here in the UrbanSound 8K. Okay. So what we'll do here is self.annotations, and here we actually want to load that CSV file. And how can we do that? Well, we can do that using pandas. So we'll load the CSV file as a pandas data frame. So here I'll do an import pandas as PD. If you don't have pandas installed, you can easily do that launching your console and doing a pip install pandas. Cool. Okay, so I'll do a pd.read CSV and I'll pass in the annotations file. This way, I will have a pandas data frame that has all the information that we say in that CSV file. Next, I want to create another attribute called audio directory, and I'll pass the audio directory here. Now that we're done with the constructor, the next step will be that of creating or implementing our len magic method. So what do we want here? Well, we want to return the number of samples that we have in the dataset. And this is easily achieved by doing return the length of our data frame, our annotations data frame. Okay, next, we want to implement the magic method getItem. So what do we really want here? Well, what we want to do is loading the waveform of the audio sample associated to a certain index, and then at the same time return also the label associated with it. So the first thing that we want to do here is getting the path to the audio sample. So we'll do audio sample path, and that's equal to a private method that we'll implement in a second. It's called self._get audio sample path, and I should pass in the index here. If you're wondering why we are using another method here, it's because the process is a little bit convoluted, and I just want to put it in its own box. Okay, so now we have the audio sample path. What we want to do next is to get the label. Okay, so the label associated with this sample path. And so here again, I'll be using another private method. So get audio sample label index. Okay, so we'll implement this couple of private methods in a while, but for the time being, we have the audio sample path. So what we will do next is actually loading the audio file. And we'll load it using Torchaudio. So let me just import Torchaudio. So we'll do import Torchaudio here. Okay. So, and for actually loading the audio file, what we'll do is using the load functionality in Torchaudio. Here we are in the Torchaudio documentation. So there's a module called Torchaudio backend, and this module is responsible for all things that have to do with I/O functionality, so input, output. So depending on the type of machine you are on or operating system, the backend used by Torchaudio will differ. So for example, if you are on Linux or macOS, you'll be using as a backend sox_io, sox.io, but if you are on Windows, you'll be using Soundfile. But regardless of the backend that you'll be using, you have a similar interface for this I/O functionalities. So some of these are torchaudio.info to get information about the files that you're loading. Then torchaudio.load, which is the one that we'll be using, torchaudio.loadWave, and this is kind of a subset of load because it's focused mainly on WAV files. And then you also have torchaudio.save that you can use to save audio files. We'll be using torchaudio.load, and this function returns a couple of things. It returns the signal, which is the waveform, a time series of the audio file, as well as its sample rate. And so here we'll do a torchaudio.load, and we'll pass the audio sample path. Okay, and finally here we'll return both the signal and the label associated to the signal. Okay, so now we have our get item, but of course we haven't implemented these two private methods, so let's do that. So we'll implement first the get audio sample path, and the argument is index. So what we want to do here is basically take the path to the audio file, or the file that we are interested in. Now let's take a look once again at the CSV file, the annotations file. So here, as we said, we have the slice file name, the file name, we have the fold, and these are the information that we need to get to the audio file path. And let me show you why that's the case, because if we start from audio, so this is the audio directory, then we go in here, and then we have fold 1, fold 2, fold 3, say fold 5, we can enter here, and then we have all of this slice file names. So we have to put together all of those elements. So the first thing that I'll do is identify the fold, and here I'll create an F string, and I'll say fold, and here I should pass the number of the fold, and the number of the fold is this one here, right? So in this case would be 5. Okay, so how do I get this cell, the value for this cell in a data frame? Well, I can use iloc, so pandas iloc method. Okay, so let me just go back here and I'll say self.annotations. So this is our pandas data frame. Then I'll say iLock, and here I should pass the two coordinates to get like the cell. So the row is equal to index, the column then is equal to, in this case, 0, 1, 2, 3, 4, 5. Okay, so I'll pass in 5. Okay, so now I have the fold. What I need to do now is join all of these paths. So the fold, the audio directory, and the file name. So for that, I need to import OS. So I'll do import OS, and I'll use path. Okay, so let's call this path, and we'll say os.path.join. And here we'll pass self.audio directory, then we'll pass the fold, and finally we need to pass the file name. So basically this, okay, something like this. So for that, we should again use iLock on our self.annotations pandas data frame, but this time we'll as the column number index, we'll be using 0, because this is like the 0 column, 0 indexed column. Okay, so let's go back here. We'll do self.annotations.iLock. We'll pass the index, because that's the row index, and then we set 0. Good, and here we can return the path. Okay, so now get audio samples path is ready, and it returns the path, the file path associated to the audio sample that we are interested in. Okay, so what next? Well, we need to implement get audio sample label. Okay, and here again we'll pass the index, and I'm sure you get the gist of this, and in order to do that, we'll do a self.annotations.iLock once again, and we'll say index, and we need to get the column index here. Let's take a look at it. So we need this class ID here, which is at index 6. So it's the 7th column, so index 6. Okay, so we'll pass 6, and I think we are done here. Okay, so let's take a look at what we've done real quick. So we implemented the UrbanSoundDataset class, which is a concrete PyTorch dataset class, and the two main things here are implementing the length magic method as well as the get item. And so as a result, when we call the get item, we'll get back both the signal as a waveform and the associated label to with respect to a certain index. Let's create a script and see if it actually works well. So we'll say if name is equal to main, then first of all, we want to create a USD, which stands for UrbanSoundDataset object. So we'll do UrbanSoundDataset, and here we should pass a couple of arguments. So the annotations file, so let me annotations file and audio directory. Okay, of course we need to define these two constants, so annotations file and audio directory over here. And I'm going to cheat here because I already have them here in Gedit. Okay, so this is the annotations file, and this is the annotations directory on my machine. Okay. Cool. So now we have a UrbanSoundDataset object. So let's say print there are. Oh, let's make this an F string. There are lang USD. samples in the dataset. Okay, so that we'll see whether lenUSD actually works. Next, I want to try out the getItem magic method, and so I'll take a USD at index 0, and I should expect a signal and a label as an output. And so here I'll say USD at index 0. Let me put in a dummy expression here so that I can debug and stop here and get a look at signal and label. So let's run this and see the results. Okay, yeah, first of all, let's see if we printed this. So we go to the console and it says there are 8,732 samples in the dataset, and this is actually correct because this is the number of samples that we have in UrbanSoundDataset, and that's fine. So now let's take a look at the debugger and the signal here. So here in the signal we have a tensor which has shape 2 and then this, and that's fine because 2 is the number of channels that we have in the audio file, and in this case we have like 2 channels probably. So this is a stereo audio file, and this is the number of samples in this audio file, which is good. Okay, and then the label is 3. Let's take a look at the expected label. So as you can see, for the first sample, the label is 3, which is actually correct. It's a dog bark. Cool. So yeah, this seems to be working fine. That's great. Okay. So by now you should be able to create a custom PyTorch dataset. Not only that, but also load audio files using Torchaudio. This is not enough for what we're going to do here, because of course we want to build a classifier so that we can discriminate among the different sounds in the UrbanSound dataset. But for that, we're not going to use waveforms to train our model, but rather we're going to be using MEL spectrograms. So in the next video, we'll take a look at Torchaudio transforms, and specifically we'll be focusing on how to extract MEL spectrograms and extract them directly within our custom audio dataset. So stay tuned for that. I hope you found this video interesting. If that's the case, please leave a like. If you want to get more videos like this and you're not subscribed yet, please consider subscribing to the Sound of AI channel. That's all for today. I'll see you next time. Cheers for now.